In this video, I will introduce you to chemical equations and give you some of the clues you need for interpreting what you see. Now that you know how to name and write the formulas for chemical compounds, we'll be working with chemical equation. So what's in a chemical equation? What does it do? Well, basically, a chemical equation summarizes what happens in a chemical reaction. So it's a short form of the most important information. It identifies the reaction's inputs, which we call reactants, and the reaction's outputs, which we call products. It also tells us how much of any particular reactant or product is needed by the coefficient in front of the formula, and sometimes we'll give you the phase of matter or the state of matter for each component in that reaction. So here are two chemical reactions to look at. The arrow here is our dividing line between the reactants and the products. So we have our reactants on the left and the product or products on the right for both of our equations. In the first reaction, we see we have dinitrogen pentoxide, which is a solid. This is what the little S says. That reacts with water as a liquid, and it produces some nitric acid. HNO3 is an acid, and this acid is in water. We say it's an aqueous solution. It's dissolved in water, so that's what the AQ stands for. With the coefficients, you see that there are two molecules of our nitric acid here designated, but there's no number in front of our dinitrogen pentoxide or the water, but there actually is. There is an invisible 1 in front of these two compounds, just like in algebra where you'll have an x and it really is just 1x. We have invisible 1 coefficients in chemical formulas as well. Our second equation, we have two, so our coefficient tells us we have two molecules of aluminum hydroxide, which is a solid, and it actually decomposes into two different things. It decomposes into aluminum oxide and water, and this water in this time is a gas. So we have a different state of matter given there. So the four symbols you see for state of matter is S for solid, L for liquid, G for gas, and then AQ for aqueous, which means a solution of a solid dissolved in water. Now, chemical reactions will be described either as a word equation, which you have to then interpret into a formula, or a formula equation where they've already figured out the compounds for you. For an example, here we have a word equation. Magnesium metal it should be reacts, not reactions. Magnesium metal reacts with a solution of titanium for chloride to produce solid titanium and aqueous magnesium chloride. So we have hints of the phase of matter in this word equation along with the names of the compounds. We're starting with magnesium metal, so that is the pure element, so that's just the Mg. And since it's a pure metal, it's going to be a solid. It's going to react with titanium chloride, and so I would have to figure out the formula. Chloride has 1 negative charge, and so the titanium would have, in order to balance off the positive 4 charge for titanium, which our word or the name here tells you that. Remember, the Roman numerals with the 4 is telling you that you have a charge of positive 4. So we had to put 4 chlorides in there. And it is a solution. The word solution tells us that it is aqueous. It is a solid dissolved in water. And then it produces, so that's going to be where our arrow is going to form. So now we're moving from the reactants to the products. It produces solid titanium, so that is the titanium metal, and aqueous magnesium chloride. So then we'll put the magnesium and the chloride together. And of course, since magnesium has a positive 2 charge, the correct formula would be MgCl2, not Cl4. So we have to have 2 of those to balance the equation. And we're going to get to balancing equations in the next video. And then, of course, this is in solution, so it's aqueous. We have the AQ symbol after there. So you will be asked to turn word equations into formula equations throughout the rest of the course, and it's just interpreting what it says in the word equation and then putting it into that chemical formula. You learned several weeks ago that certain elements are bonded together into multiple atoms making up one particle or one molecule, all the same kind of atom. So the element is a molecule, not an individual atom. And there are several that you're going to need to know about in order to manage dealing with chemical equations for this course. And these are the elements that exist as two atoms bonded together. They're known as diatomic elements. And when you are writing these elements into a chemical equation, you must write the diatomic version. I have no idea why that came out with a slightly smaller font. So I have some examples over here. We've got some interesting things that happen to my pictures too. I just love transferring programs sometimes. You never know what's going to happen. But this will be an illustration of a diatomic element. You have two atoms that are exactly the same bonded together. An easy way to remember the most important 7 diatomic elements are to think of things that end in gen. So the 3 common gases that you are familiar with probably from biology, hydrogen, oxygen, and nitrogen, they all end with this gen ending. They are all diatomic elements. So if you were writing them in a formula, we would be writing H2 or O2 like we did all last year in biology, or N2. And then it are the elements that are part of the halogen group, specifically fluorine, chlorine, bromine, and iodine. So if you are dealing with a word equation that has chlorine in it and you're writing out the formula, the elemental chlorine would be a Cl2 as well. So these 7 diatomic elements, all the things that end in gen, hydrogen, oxygen, nitrogen, and the 4 halogens that we'll be working with are ones that you just need to remember. So finally, your steps for turning words into formulas. Well, you want to first identify what are the reactants and what are the products from the word equation so that you know what to put on the left side of the arrow and what to put on the right side of the arrow. You want to write the correct molecular formula for each compound. And that means starting by asking yourself the question, is it ionic or covalent? Because that's going to determine how you write the name. If it's ionic, you'll have to figure out, is it a single charge or a multivalent metal? And so if that's an important piece of information. And then looking at the, is it a binary or a ternary ionic compound? Are you going to be looking at the polyatomic ions or the regular ionic, or just the regular single charge ions in your periodic table of the ions reference table? And then if it's a covalent compound, then you want to look at what prefixes are present in the names that you've been given in the word equation so that you know how to write that formula. Once you determine the molecular formula, the next thing to do is to arrange it in an equation. And if you have phases of matter, if they're given, go ahead and put those in as well. And then last, you will balance the equation. But you don't have to worry about that yet. Those details are coming in the next video. So before we get to balancing, I want you to have some practice turning word equations into formula equations. There'll be several worksheets you'll be working on in the classroom where I will be available to help you in case you get stuck.